Some would say that the Model T is the basis for all cars, but I would argue that the production of the Model T is what's really important. The assembly line is used for many different things and is a very important system that we use in everyday life. From parts, engines, and even foods, we can see assembly lines in our everyday lives. But today we will explore Henry Ford's Model T assembly line. The assembly line was definitely a success, increasing the production of one car from 12 hours to 2 hours and 30 minutes. Here we have a basic setup of an assembly line, and as we can see, you have to move through different parts before you get to other certain parts to continue the line in the chain of events. So here we start, and then we can either move to station A or station B. And depending on which one we choose, we can either move to station C or station D. And then we move to station E, and then we have our finished product. And as we can see from this sketch, we have key nodes here. Now these key nodes play an important part of the assembly line because we cannot go to station A or station B without starting here first. So this is a key node. And then after D and C are done, we cannot finish the product without moving through station E. And that is why these are central nodes. Now if we took these nodes and moved them here, say example from key E and moved it to the middle of the assembly line where A and B had to be done before moving to E, we cannot do that because D and C have to be finished before moving to node E. So that will move the assembly line around and have to make us adjust to a different type of assembly line. So this here is called a central node. The assembly line has pros and cons. Unlike a project, an assembly line does not use a one-time standardized way of doing something and you just don't get one product. And unlike batch production, it is much more standardized and you get a lot more product out of the production. Mass production is where the assembly line comes in. It is very standardized and you get a lot of output out of the input. Continuous production is where you have one way of doing it, it is very standardized, and you get a very high amount of output coming out. The problem with the mass production with the assembly line is that if something messes up, it is hard to go back and change the way the assembly line is moving. But unlike continuous production, with the assembly line, you still have a possibility of salvaging what was messed up, and you still can go back and change the assembly line if need be. The classification for the Model T assembly line, I would say, is definitely open because it is influenced and interacts with the environment, as the environment are the people, the workers, the people who are making the decisions on how to change it, and the people actually putting the parts together on the assembly line. But through the evolution of the assembly line, as we see now with modern day Ford cars, Dodge cars, and Chevrolet cars, now I would say the visibility is somewhat visible still, but it's definitely gray now in the color system because we have more robots and it's more automated, and it doesn't really interact with the environment as much, but it is definitely open. It is still very open because it interacts with the environment, but it is somewhat gray because you cannot see everything that is going on within this system. Here we have the system life cycle, and if we take the assembly line and take it through this model, we see that Henry Ford established the system need when he decided that he wanted to make the Model T production line more efficient. He then took concepts from other people who had a assembly line type model and developed his own system concept. He designed and developed the system how he wanted it to be and how he wanted it to produce the car. He then made the system. He deployed the system, as we say, he used the system, and then he operated the system, and I would say that the old way of doing the assembly line was retired, but the main concepts still are here, and we just started back at the beginning at establishing a system need and just made it more efficient. At each stage in development, there are definitely risks that are taken. With establishing the need, there is definitely a risk of messing up and not identifying the correct problem that you have. Developing the system concept, it could be you do not actually design the concept how you really want it, but that starts at establishing the need. Design and develop the system, you could design it the wrong way. Produce a system. This is the longest stage in the system life, and it could take too long to produce a system to where then you have to establish another need. Deploy the system. You could also take too long to deploy the system to where you don't need the system anymore. And operating the system, you could always run into problems such as people not knowing how to operate the system correctly, and then retire the system. You could retire it too early, or by the time you get to produce a system, you might need to directly retire it because it took too long to deploy. One ethical consideration when putting together the system was the safety of the workers in the system, and also a stakeholder at each stage of the system life cycle was definitely Henry Ford, who had the most to lose from this. The system has definitely evolved over the years using robots and humans to work together now to produce more efficient cars and a more efficient system.